Okay, I think we are kind of in the beginning, so let's see. There might be people dropping in, but I think we give it a go anyway. So welcome everyone. Very nice to see you here at this fireside chat, as they call it. It was pretty new concept to me, but my name is Thomas Arts. I'm working at Quviq, and for people that don't know that, I'm the guy that say, don't write test cases. That's a waste of time. Just have them generated automatically. That's the way you go, right? So quick check like things. Today we have as our honored guest, Brooklyn. Brooklyn, probably would like to introduce a little bit yourself to the audience, and then we have this chat, and I already now invite everyone to be participating in the chat. If you want to say something, please go ahead. You're always welcome. We try to be as open as possible here. So please, Brooklyn, say a few words about yourself.
Sure, yeah. So my name's Brooklyn Zelenka, or Brooke, if you prefer. I'm calling in from Vancouver, Canada, out on the West Coast. And I've written a few Elixir libraries. The main ones that I'm known for are the Witchcraft suite. So Witchcraft, Quviq, Algae, just kind of bringing the classic FP combinators into Elixir, some algebraic data structures, and some common abstractions, especially from Haskell. So I sometimes say it's porting the Haskell standard library into Elixir. And exceptional is the other one that people sometimes know, which is error handling. You can kind of think it as a pipeable with statement. Because it actually may come up in this session, I previously did standards work on Ethereum, especially around the virtual machine, and making it more understandable and analyzable. And these days I'm the CTO at a company called FISSION, where we are making web apps work more like native apps. So they run entirely client-side in the browser, or transparently can get a little bit of extra power pushing things out to the edge. So ends up being really nice for rapid development, low latency applications, personal data stores, or things like IoT.
So very, very much done already in this area, so that's very nice. So you already mentioned those libraries, and if you can say this Haskell library brought to Elixir, it's more than the library, I guess, that you envision to have there, right? So as when I look at your library like Exceptional or Witchcraft, it's a lot like getting the way of functional thinking into Elixir as well. The more and this was also posted in the beginning when I was asked to have a chat with you in this session, that, well, you wanted to bring FP, functional programming, to Elixir, on which my comment was, well, it is a functional language, so what do you mean?
Yeah, sorry, continue.
Go ahead. What do you mean by that?
What do I mean? So this is how it was pitched at me, and I've often had people say, Witchcraft is the missing functional library for Elixir. It's like, well, but Elixir is a functional language. It has all of the key characteristics, right? Data structures are immutable defaults, right? Like all of this stuff. I think a lot of people hold up Haskell and the Haskell style as the real FP, and I don't think that's totally true. When I say I'm bringing some of the classic FP idioms, it's mainly from there was work done in the 50s, 60s, and 70s to codify. This is what the real basics of SKNI combinators, or having things where you'll stub out arguments with an identity function, things like that. Bringing these ideas from Haskell or similar languages into Elixir really is just meant to enrich what's already there. What's already there and what's good. It's entirely a stylistic choice. People will sometimes say, well, but the major advantage is when you have a strong type system. And yeah, You have to be your own type checker when using Witchcraft. But it's still, I've used it in production. I've heard from people, other people using it in production. And the idea really is to just make things more understandable and to control complexity by using what is essentially design patterns from other parts of the FP ecosystem.
So you lift basically the abstraction a little bit and say, well, if you work on this abstraction level, then things work much nicer because there's some functional programming features that you can use. So could you mention a little bit of an example of what Witchcraft could do for you in practice?
Yeah, absolutely. I guess really part of the suite, because it also depends on the data
Just
structure
and
whatnot. Yeah, sure. So error handling is a common one where people want to, I would actually say exceptional is probably a better use case for that, but I've had quite a few people say, well, we want more like eithers or a result type where we can then map over it and only deal with the happy path until much later and have some sort of short-circuiting behavior, or, and this is really what I was.
Let's go a bit more into detail there. So you say you have only write the happy path, and that's exactly what normally an Erlang programmer or Elixir programmer would do. And you would just throw an exception. Somewhere else you catch the exception. So that's already in place. What is the kind of thing you add on top of that that makes it cool?
Yeah, so because everything becomes reflected directly in data rather than relying on side effects like throwing an exception, you have a really good understanding of the code. And so when you throw an exception, you end up just somewhere else, right? And it really depends. It's not local anymore, what's going to happen, right? Where that gets caught, if it gets caught, is unclear. And so this forces it down into your context while not having to handle the error directly, like, in line. But you still end up with, at the end of the statement, did that succeed or fail? And the additional advantage of handling things purely is you can still say, I'm going to let the caller handle this because I'm too low, in the program to understand the context that I'm in, but I don't want to handle this right now, and I'm going to hand this off to somebody who knows better about my context. And that's just done in pure data.
Yeah, and it's a little bit the same idea as this throw catch, because that's what you're trying to achieve with having a supervisor. On this context, we know what to do, and then below you can crash. So does it interact with processes as well, or is it purely functional in the sense that you cannot get your exception out of that context into another process?
So you can, but that's not the intended style, right? Yeah. So there's nothing preventing you from writing to disk halfway through your, and doing some error logging. Totally works. But the intended style is to keep things more in, codified in some data structure, and have a really clear idea, because everything's pure and referentially transparent, and all of these nice things. That is often the draw for functional programming, is, well, it's just, it's more declarative. I can just sort of look at it and understand what's going on.
Yeah, to me, functional programs very much like, if I look at the part of a program, I can understand that part without knowing what the context is doing. Correct, and this is also a little bit like that. You know what is going to happen with this error message because you have the whole context in front of you. On the other hand, I like this idea of Erlang not bother at all and just throw an exception and then, oh, let it crash. Someone else will catch it and will do something with it. And you say, well, you can do both, but sometimes this is better and sometimes that is better.
Yeah, absolutely. It's on the let it crash front, often the right answer. I've actually seen this in production when there was a lot of crash. And when you have something that's highly concurrent and you have, a million requests a second and 1% of them are crashing, that's a lot of crash and recomputation. And so having the ability, not everything should be recovered, right? There's a lot of cases where it should absolutely just get out. But there are cases where you're saying, well, here's the two code paths that I might go down, and they're both valid. I just need to know how to recover from this one and continue going.
Yes.
Yeah.
So that's one thing you did, this exceptional library, and this part of Witchcraft. Is there anything else that you could highlight that was cool in that library that people should use more?
Yeah. The other part that's probably maybe even more popular is in one of the sub-libraries, LG, which just gives you a nice builder for data structures, right? So a declarative interface so that you can have something a little bit more structured, a little bit more nested. And when you combine these two, there's, so we have protocols in Elixir, which gives us some degree of abstraction. But then, okay, so now you have different ways of implementing this interface. But they should be in Witchcraft, they should be principled. They should have properties that you understand and that you can test and that you can in fact quick check underneath. And so having a better understanding of the properties and the way that the exact bit of code is going to work really increases your understanding of how different pieces interact, gives you a higher degree of confidence in your code, better reuse, because you know, well, it's just scoped to this way that it works. It doesn't have to touch any of these other things. I know that I can run this in a concurrent setting because it's, say, maybe it commutes. And so concurrency becomes very easy because now we can just gather messages together, that kind of thing.
If I think of doing a data type in Elixir, I would use a struct most likely and say, oh, this is my struct as an underlying thing, or I could put it in whatever I want, but it should not be visible, right? That's the whole thing of the abstract data types. Yeah. And then you will have some API functions to deal with that. And what you say is, well, you also add additional things like properties of those API functions, like this is a commutative operation. It's not just an operation, but it's commutative. And you add that as an extra knowledge to that library. That's what you try to achieve here. Yeah, exactly. So often this gets used inside of other libraries, specifically for for these kinds of things, and it's built right into the DSL of okay, well, you're defining what we call them type classes borrowed from Haskell, right? But essentially a protocol with some properties that you're going to then go and implement, which also has the added benefits that when you're testing, now you have a well understood, this is how it's going to behave. So if that's some complex logic, and you still want to test exactly that implementation, but instead of doing all the setup and tear down and complex things, you can now start testing against a model and mocking very effectively, and not having to set up a very robust mock, but just one that behaves in the ways that you understand. This thing commutes, or it's associative, or it behaves in some special way. So it makes it simpler to test that kind of code, basically, because you have more specified, and you can use that specification in two ways, either for testing it itself, or when you use it as a mock, or as something below, you can mock it because you know how it should behave, and therefore you don't have to put the whole thing in place, but you can just use the mock. But of course, you could also use the actual code, but then you get more precision in your values. Yes. Yeah. And I think that's probably the best word for it is the precision, right? A lot of folks that I've spoken to most programming communities aren't used to these design patterns, which add this extra layer of precision. And in the same way that object-oriented programming developed design patterns, these are all these are all techniques, right? And just because we're so used to writing things in a particular way today doesn't mean that we can't evolve that and have it be more understandable and make really the job as programmers to control complexity, right? So being able to break these up into different concepts and also communicate with other people on your team about, well, this is how it works, rather than having to just read the code and say, oh, I think it kind of works like this, is really helpful. Yeah. So in classical kind of Haskell style, you would use the types as a way of communicating how things would work. And how would that kind of look like in the Elixir world then? Because of course you have your library, but you still have to communicate, this is how it should work. So how do you go about that?
Yeah, so LG has, as part of that data type builder, does produce type specs, but of course those are less, the type checker isn't as aggressive, we'll say, as the Haskell type checker, right? But it's mostly there as documentation for other people. Right in the spec, when you're writing the properties for it, so this is something that Haskell doesn't have, are listed the properties, and you name them, and they get run, well, today they get run at compile time. That will be moved to generating test cases in the future, but it's still written down. This class works like this underneath, or these are the assertions we have about it at least.
It's reasonably formal, so you could use tools to actually help you then in generating test cases or analyze your code or whatever you want to do. So you basically, by adding some more information, you get easier tool access to analyze your code, do all the things with your code that you probably would not have done with your code. Yeah. So in kind of bigger real life projects, do you have some kind of nice project where you could say, oh, here it really helped me to have this more abstract way of working?
So generating tests is the one that always comes to my mind first, because again, we've in general brought everything down into a pure setting, which makes it much easier to test, right? As you said, you don't have to understand the entire context around it. It's just this piece here can be, pulled apart and plugged back in on its own. And so wiring that up to tests is very easy. This is one of the major advantages of having a more pure style, less setup, less tear down. So I work at a startup, and it's people always talk about, well, you have to move really fast, right, and iterate constantly. And having a really good understanding of what's happening inside of our code has sped us up, absolutely, like no question. We write code and we don't have to touch it again for maybe ever, right? Because it's not that it's well specified and written down in a spec that's been done in LaTeX or something, right? I understand how this piece of code works. We may have some additional documentation, but the code is broken down, really well understood, and it's not constantly together like this anymore, right? We can really start pulling things apart and understanding, okay, well, this runs in isolation, this runs in isolation.
You have nice
and then
blocks that you can put together. So
exactly,
what I normally see in my projects is that we have a lot of those projects where the requirements are a bit fuzzy. So you will make something and then people say, oh no, that's actually not what I want to have. And then you build something slightly different. And of course, the trick there is to have the right building blocks from the beginning. That helps you enormously, but also to quickly be able to rewrite your code. To say, okay, throw it away, do it again. But if you're on a high enough level of abstraction and you have the high level building blocks, you put that together much quicker, of course. And I think that's also where this functional programming style kicks in nicely, is that you don't have to do all the details because you've done them once and for all, but you can glue things together quickly and make it work. And also this isolation that you indeed can look at one module and say, is there anything in this module that I can use, or shall I just throw it all away? And it's all kind of well contained, and this is a nice function to have, or this is a pattern that I want to reuse, and that works really well. So that's indeed, we see benefits of that kind of programming. And also the maintainability of well-defined abstract code is of course a little bit easier, although it depends on who has to maintain it, right?
Sure, yes.
There you have the other side of the coin, that if it is too abstract and complex and you want to change it a little bit, that might be relatively hard to do. So how do you go about that?
Yeah, so in general, and as you said, it really depends on the situation and the team, and premature abstraction is a real danger in itself, right? But I'm very much a fan of the 3-layer architecture. So a lot of people have heard of functional core imperative shell, where you have all of your, and we really try to expand, especially with things like witchcraft analogy, expanding that functional core where everything is, very well defined and very, defined in data and doesn't need to understand other parts of the context. And then you wrap around it, this skin that is, imperative. It's not just side effectful, but, it's saying, I'm going to do things in this order. It's less declarative, it's more imperative. And that's a common pattern in lots of ecosystems. You can stick another layer in between those two. That's sometimes been called the object-oriented layer, or the DDD, the domain-driven design layer, where you're really describing the concepts in your application, making them abstract, so protocols or type class. And now you have this complete separation between your data structures and these nice composable pieces and that imperative skin on the outside, because they talk through, here's the concepts that are in my application, that are in my domain. You might be working for a social media company, and you'll have tweets and users and all those things that you would normally stick in a database, and you still in fact do, but decoupling these, and now again, test benefits, you don't have to have a database behind it, you can just put a mock there, or as you're changing bits of code, you don't have to keep updating the imperative shell, because all you're saying is, I'm updating a user, I'm deleting a user, I'm going to schedule a tweet, or whatever it is.
Yeah. So this layer that you described, you already mentioned the Elixir protocols, which is also kind of a layer in between things. Mm-hmm. Would you say this has a very close link with DSLs, that you always need a DSL to describe that layer? And how would you, or is it just more like you can choose whatever, but we often use DSLs for doing that? Oh, DSL, for those joining in and don't know all those abbreviations we are talking, is domain-specific language. So you can, in Elixir and in Haskell and Erlang, you can very easily define your own kind of subset language, which has a certain purpose. So is that the kind of thing you envision, that you want to have lots of DSLs around to make life easier?
Yes. So DSLs are very useful, because now you're just describing your domain, and the question is, what is your domain? Is Ecto, is a DSL, even though it's still fairly low level. You're talking about the database, but that is exactly the domain for that part of the application.
For those of you that are a bit unaware of Elixir, is taking the model of your database, basically, right, and the relations, and puts that into access functions, I guess, and the database schema and everything of that. So you write basically, oh, this is the kind of relational data schema I want to have in my application, and then you generate all the necessary code for that, and your database schema and all that. So that's correct, right, Brooklyn? Yes. Or did I? Yeah. Okay.
Yeah.
So,
yeah.
So it's actually a DSL, because you take an abstract notion of an entity relationship datagram, you describe that in a certain language, that's your DSL, and then you use that to produce all that code.
Yes. Yeah. And a lot of people think of DSLs as this, very special, writing a language suddenly. Well, most programming is defining your terms and, the verbs that are going to operate on these, various nouns and all these things. So you're always generating some kind of DSL. Doing it in a domain-specific way is very helpful, because now you have not just common language within the engineering team, but also across with the rest of the organization. Here's concepts that, oh, well, we had to actually specify this in codes. We had to break that concept down. Here's how that actually works. Here's how those pieces interact. There's two ways of doing DSLs, like, very broadly speaking. First is this, deep embedding where it's directly in code. You've written protocols, you have functions that are operating on them. Maybe you have some common data structures or a database table, but you're really fundamentally writing a DSL in the language that's going to interact with everything else. The other way of doing this is to create essentially an DSL's AST, or abstract syntax tree. So you can express this directly in data and say, here's how, here's a description, purely declarative description in data that I can then take, tear down, and interpret at runtime.
Yes. That's typically done like a configuration file or something. That is an easy form of that, but it gives you how you configure it, and you have a special syntax and special meaning of the things. What you write there in your configuration file is how the program is going to behave.
Yeah, exactly. And so the common thread between both of these really is that we're making the code more declarative, right? We're trying to say less about how and more about what we're talking about.
Yes. And for example, the quick check primitives are typically an embedded DSL, because there you use different language fragments to express yourself something and generate tests from that. So that's a really embedded one. And Ecto is also really embedded DSL. So that's the difference. And of course, Elixir is fantastic for doing this, because you have this nice macro system that you can use to express a new language inside an already existing language, which may be like the original language, but gives a completely different meaning to what you're actually writing, which is super nice and also relatively dangerous, because at a certain moment of time you get this code to read and you think, what the hell is this code? Is this Elixir? No, it does look like Elixir, but is it Ruby? No, it's not Ruby. What is this doing? Because you don't know all the definitions of all the macros that have been defined in order to get there, right? So there's also some kind of tricky issue with this DSL design and writing. Do you have a special way of treating that? Is it, in your view, a documentation matter, education matter, or how do you kind of see that part of the difficulty?
Yeah, I would say that the first rule of macros is don't use macros. And I say this as the person who's probably abused macros more than anybody in Elixir. It's really the major distinction between the two there is, macro code can be very, it's extremely powerful. It can be very confusing to write because you're juggling all these extra layers. The major difference is macros, other than that they're operating directly on the language, they happen at compile time, which is I find like the real challenge when thinking about them as well. I'm getting the performance benefit of this is generating things beforehand, but this can be put into a function as well. And often functions will get the job done. So I'd say avoid as much as you can, just because it makes it easier to think about and easier to communicate in regular code. If you need to drop into macros, make sure that it's well documented, well understood, and really keep it as isolated as possible, because they're just more difficult to maintain. Not to say impossible, you can absolutely get used to writing them, but it's one of these things where people are, because I used to teach Elixir as well. People are very afraid of macros, and then they discover, I can actually like decompose the program itself and start operating directly on it, and they go completely wild with them, and feel really good, and a week later they can't read it, right?
But they have a good time.
But they have a very good time, exactly. Yes, yeah. So yeah, the first rule of macros is don't use macros, asterisks, except when it's actually useful. It's very powerful when used appropriately.
Yeah, and that brings us a little bit into understanding code of your own code that other people write, code in a big project that you're thrown into. And then we come back to what you started with, this, try to use more abstraction, because then you can probably understand that code better. And I was just trying to fish for kind of an anecdote here, where have you experienced that in real life, that the way of abstracting would actually help you understanding code that you're thrown into much better than when the abstraction would not have been there.
Yes, though it's, I'm trying to find like a good example without without getting too into the weeds about specific situations. But really fundamentally, it's when you have this shared language or this easy way of pulling things apart. This is a big part of the style that we have at my company FISSION, is having well-defined abstractions and really having things pulled apart. Onboarding people becomes mainly a matter of saying, well, here's the concepts that we have and how to interact with them. And something's broken, great, go and change the implementation and it's fine. Everything continues to work. You haven't because we're not, everything isn't, all together like this. You've changed this bit there and it's not going to go and affect this other section of the code that feels totally unrelated because the concepts are separate and really, really clear.
Yes. Hey, you told me about the cross-border project or the cross-border stuff before. I don't know if you may tell anyone about this, but that was a cool story.
Yeah, sure. So this was a few years ago. I was working at a fintech company doing cross-border stock trades on, or securities, I guess, on the blockchain. So there had been a number of major, so on Ethereum, for those of you who are aware, right? It's second largest blockchain programmable as well. So you have smart contracts, and the virtual machine and the main language Solidity are not the greatest. And so around that time, there had been a number of really major bugs in major smart contracts in code that cost, on the order of hundreds of millions of dollars of people's money just getting locked in accounts that nobody could access. So I was brought in to write a language that would be understandable to lawyers, so they can, no coding background, but they need to be able to read it. And that can be checked for various properties that say that, yes, in fact, this is regulatorily compliant in Canada, the US, and South Korea. And have that checked at, ahead of time, that we understand that, in fact, it hits all of these things. There's no, it'll only run in a certain amount of time, and it only, or a certain number of steps, and, doesn't do certain things, right? That's really the main check. And it was, I like to say, the unholy union of Prolog and COBOL, because it was this really high level language that was just, here's some statements that we're going to make, you're only allowed to start trading these things after 6 months, and, et cetera. And underneath it did fairly extensive checks on this just data structure, just static data structure, that we would then turn and generate code out of. And it made it this very difficult problem that otherwise, literally, again, a team of experts had introduced a small bug into and cost hundreds of millions of dollars. It made it so that we could actually understand what was going on. And it didn't matter as much as long as we could have a really well-tested implementation of that, going from that data structure into native code on the Ethereum virtual machine. And we could test that, extremely well. Then the high-level DSL all just worked, and actually ended up being a really, really nice way of working, and also, communicating across not just engineering, but engineering and legal.
So that's another example of how DSLs really helped you in real life. So time is flying, Brooklyn, so that's probably a good sign. But I would really welcome also a little bit of questions from the audience. If people have something to tell or want to contribute to this, then please go ahead, because I think we have 5 more minutes left, and there's plenty of time for some extra questions if you like. Some more about Witchcraft or the other libraries that Brooklyn wrote, or some more general about DSLs, probably. seems all crystal clear, or people are so shy. It's early in the morning for you, but they have had already a long day.
Yes.
Sitting and listening. Let me see. No one here? No, not even Francesca pops in with a question. Yeah, Francesca.
Not even the classic, why did you bring monads to Elixir? No.
Yes, let's take another hour. Brooklyn, how about the monads in Elixir?
No, I just wanted to thank you for this. I really enjoyed it, and especially a special thank you for you, Brooklyn. I know it's very early in Vancouver, so I really appreciate you being part of this and taking your time.
Yeah. Well, thanks for having me.
It's
always a pleasure.
It's great to hear about all the libraries you did, and I hope that the message came over that let's use abstraction. Let's do that for the purpose of all your colleague programmers that then can easier get into your project if you leave it because it's boring and you move on. Let's use abstraction for not only for your colleagues, but also to analyze your code much better, because you can do that when you have abstraction, and you can probably generate test cases from your code, to do other things with your code, or your documentation is generated just because you have more abstraction. And all these things help you in being better software engineers. And then you use the fantastic libraries that Brooklyn wrote and you get even better. So yes, thank you very much, Brooklyn, for being here. Thank you all for listening, and hope to see you again, probably in real life.
Hopefully. Thank you.
All right.